the properties of normal distribution. The property of normal distribution, property 1. Normal curves are density curves. Okay? And normal curves are symmetric. And bell-shaped. So, say X is a variable of interest. Since it's a density curve, so X is a continuous variable. Okay? And, or you say continuous random variable. A normal curve is symmetric and bell-shaped. This is a bell shape, okay? Now, here is the center of the X distribution, okay? And look at here, here's the center. This is the center, okay? So, suppose I tell you this side covers 50% of the area. Or you say 50% of observation less or equal to this point, okay? Since it's a density curve, everything under the curve add up to 100%. So this is the other 50%. Now, so what do you know about this point here? This number, 50% of observation less equal to this number, and the other 50% of observation greater or equal to this number. So this number is what we call median. The definition of median is that 50% of observation less equal to median, and the rest 50% of observation greater or equal to median. And also, if I place a supporting point here, I can balance what? The graph, okay? The point balance graph, we call the point is what? Mean. Why in a normal curve, median equal to mean? Because normal curves are symmetric, okay? For all symmetric curve, we have this nice property, median equal to mean. And next one, it's also equal to mode, okay? And there is an argument, okay? There is an argument. Look at here. Suppose this is a center. Suppose this is a center. And if mode is not right on the center, what happened? Then by symmetric property, you're going to see another mode on the other hand of the center. Then it won't be what? It won't be symmetric. It won't be unimodal and symmetric, okay? So, why mean equal to mode? Because normal curves are bell-shaped. And bell-shaped, that means we have only one mode, so it's unimodal. And symmetric. For any distribution that is unimodal and symmetric, the mode must occur at this point. If it's not occur at the center, as I mentioned earlier, if it's on the left-hand side, by symmetric property, it's going to create what? another mode on the other side. Then it won't be what? Unimodel. Okay, it becomes bimodel. And symmetric. So, in a normal distribution, we do have mean equal to median. And this is because what? Normal curves are symmetric. All symmetric curves, we have mean equal to median. And why median equal to mode? Because it's bell-shaped. And for bell-shaped curve, it's unimodel and symmetric. Unimodel and symmetric curve, the mode will occur at the middle, in the center. Okay? That's why. Now, next topic. Property 2. The mathematical formula that describe the mathematical formula that describe what? The density curve. The normal density curve. We denote the function as what? F of x. Okay? The mathematical formula that describes the density curve, we denote by f of x. And look at here. Say this is the variable of interest, and this is a normal curve. And what function describes this normal curve? Is f of x equal to 1 over square root 2 pi. And again divided by sigma. And then times e to the power minus 1 over 2. And then x minus mu squared over sigma squared. Okay? And x is between positive infinitive to negative infinitive. Okay? This is a functional form to describe the shape of the normal curve. Now, let me explain turn by turn about this mathematical formula. Okay? First one, introduce you pi. Second one, introduce you e. And third one, introduce you mu. And the last one, introduce you sigma. Okay? Begin with pi. Pi is an irrational number. It's 3.14159. Since it's an irrational number, it won't stop. Okay? This is the same pi when you try to find the area of a circle. Now, e is another irrational number. This number is 2.718. E is also an irrational number, so it won't stop, okay? It carries infinitely many decimal places. Now, if you have learned calculus, you will find E a lot, right? Now, next one, mu. What's mu? Mu is population mean. Mu is population mean. And we use mu to locate the center of the distribution, okay? So look at the picture here. Here is the center, this is mu, okay? Now, sigma is population, standard deviation. This one tries to describe how big is the spread. It tries to describe spread about the mean, okay? Now, it's very simple. The mu is a number located the center of the normal distribution. Next, I'm also give you a physical interpretation about sigma. Okay? If you have learned calculus, you know this kind of curve we call concave down. And a curve look like this, we call it concave up. Okay? Concave up and concave down. In a normal curve, we have both of them. Okay? In a normal curve, we have both of them. So look at here. Here, the curve from concave up to concave down. And then concave up again. Okay? In calculus, we call a curve change from concave up to concave down, or from concave down to concave up. We call the point what? Inflection point. And since normal curve is symmetric, in a normal curve, we have two inflection points. Okay? Now, if you place your eyes here, and you look down, the projection of the inflection point, the distance of projection point to the center, that distance is sigma. That distance is sigma. So this point here is mu minus sigma. This point here is mu subtract by sigma. Okay? Now, this is a physical interpretation of mu and sigma.